You start the day scanning Hacker News, X, and a dozen open tabs. By lunch, the signal is buried under product marketing and duplicate headlines. Developers and data analysts are trying to map actual industry movements, but the raw volume of daily updates makes it physically impossible to isolate real structural shifts. A Chinese open-source project called TrendRadar was built to aggressively filter this exact noise. This repository has quietly accumulated over 54,000 stars and 23,000 forks. Those are enterprise-scale metrics, yet the entire codebase is maintained by a single developer going by the handle Sansan0. The project operates as an AI-driven public opinion monitor, designed to act as an automated kill switch for information overload. The massive adoption for a solo developer script suggests that standard industry methods for filtering technical data are failing the needs of high-frequency users. For over a decade, the default solution has been RSS readers like Feedly or InnoReader. These legacy platforms rely on deterministic matching. The algorithm executes a blind query, looking only for exact keyword hits in the text. The immediate result is an inbox choked with false positives, delivering hundreds of headlines completely devoid of context. On the left, an RSS feed uses brute force collection. On the right, TrendRadar's curated Slack message. The left feed flags every Apple mention, mixing tech earnings with crop yields. TrendRadar parses meaning, rejecting agricultural data before triggering a notification. Relying on basic string matching is an obsolete strategy for analysts who require high signal intelligence. TrendRadar abandons RSS string matching entirely, replacing it with a semantic filtering pipeline. Users bypass complex Boolean search strings. Instead, they configure the system by writing out their specific interests in plain conversational language. Looking at this configuration file, named AI_interests.txt, the user simply writes, "I want AI and new energy news." The pipeline uses this prompt for semantic intent scoring, forcing the AI to evaluate the actual content of incoming news against the user's defined priorities. The logic gate evaluates context. An article on AI-generated art is rejected, while a piece on AI processor efficiency routes through. The system uses strict token optimization, only recalculating these tags if the user explicitly modifies the configuration file. Shifting from a passive keyword net to an active semantic bouncer converts a raw data fire hose into a highly calibrated intelligence feed. Scraping a clickbait headline is easy, but a headline alone rarely contains the actual substance of the article. TrendRadar bridges this gap by integrating native support for the Jina AI reader. This component executes markdown extraction. It strips away the website's graphical interface, intrusive ads, and navigation menus, isolating only the core text. A raw URL enters the Jina AI reader node, outputting clean, structured markdown blocks. Feeding full text to an AI yields vastly deeper analysis than relying on truncated summaries. This prevents the AI layer from hallucinating or miscategorizing content based on sensationalized, misleading titles. Reliable automation in trend monitoring depends on the agent processing the full body of the text to establish accurate context. With the data successfully extracted, the pipeline hands the text off to the intelligence processing layer. TrendRadar manages this phase by implementing LiteLLM as its central routing hub. This allows for completely agnostic routing. LiteLLM supports over 100 different AI providers through a single unified configuration file. This diagram shows markdown text entering the LiteLLM node, which fans out to interface seamlessly with models from OpenAI, Anthropic, or DeepSeek. This architecture eliminates vendor lock-in. If an API becomes too expensive or a server goes down, users can instantly switch models. In the final stage, the pipeline takes the synthesized insights and pushes them concurrently across 9 different distribution channels, including Slack, Telegram, and WeChat. By decoupling data extraction, AI processing, and distribution, the repository functions as a modular intelligence agent, remaining operational even as individual APIs evolve. However, examining the architecture on paper is very different from actually operating it. TrendRadar is not a polished, consumer-friendly software application with a one-click login. The barrier to entry is steep for anyone lacking a background in development or system administration. Look at this interface. Users are forced to manually wrangle GitHub Actions, manage cryptographic secrets, and debug syntax errors in unforgiving YAML configuration files just to get the workflow running. The repository's issue tracker is crowded with community complaints regarding failed builds and webhooks that refuse to fire. There are deeply technical, recurring flaws, such as a known Latin 1 codec encoding error that frequently breaks the pipeline when attempting to push notifications to channels like Entify. This is the heavy tax of open-source development. Accessing an incredibly powerful, free tool usually requires paying up front with hours of configuration and continuous maintenance. Beyond the setup friction, a severe structural fragility is hard-coded deep into the ingestion layer. The entire project is burdened by a massive API dependency. It relies almost exclusively on the external News Now API to fetch its data. If that single, undocumented third-party source alters its data structure or suddenly shuts down its primary servers, TrendRadar's entire semantic pipeline collapses instantly. These technical vulnerabilities point to a much broader issue regarding how we consume information. By constructing perfect, automated filters that only show us exactly what we ask for, we have to ask the critical question: are we ultimately outsourcing our own intellectual curiosity to an AI? If mapping out this architecture saved you time, hit subscribe so you can stay ahead on the exact tools reshaping the industry. To see how these automated systems handle deep dive investigations, check out our breakdown of autonomous AI research agents right here. Stay ahead of the noise. We'll see you in the next investigation.